There we go. Now we're recording.
Alrighty, who wants to pray?
I can go ahead.
Okay.
Our dear Heavenly Father, we're grateful for this day that we've been able to come here together and to be able to study together about this math course. Father, we ask Thee to watch over us and bless us with insight, that we may be able to be guided by the Spirit, that we may be able to learn and retain this information so that we may be able to gain a greater knowledge in this subject. Father, we ask Thee to bless those who are on their way to this meeting, that they may be able to come here soon, that they too may be able to be edified, and that we may continue to be successful in this course together. Father, we're grateful for all of the blessings we receive from Thee, and we say these things in the name of Jesus Christ. Amen.
Amen.
Perfect.
Oh, I think next week my but anyway, English paper I need help. Yep. Yeah. So you should help me to make it to where it's like perfect. Because next week the part two rough draft is due. So you should help me make it perfect so that it's perfect. And there's nothing wrong with it. And she can't say anything is wrong with it, even though it's a rough draft. Get your butt out here. Put that away. I'm not putting it.
A couple different conversations here. Let's see. Where is the group stuff? Okay. Team discussion. Discuss and make sure each team member understands the 5 different transformations and the 5 important points for transforming the sine and cosine function graphs. That was the prep work. I mean, I guess for me, the transformations aren't as difficult because I just think of the functions, because they essentially do the same thing, but now we've got a new one that changes the, what do you call it? It changes like the period of it or how much it shows up in a segment. I don't know what the proper term of that.
A period. I think this first question is just like a review of like what we've learned from functions in the past. Like the A, if it's negative, then the function is reflected, and like the H like shifts it to the right or to the left depending on the sign. And same with the K, but it like just shifts it up or down depending on the sign.
Mm-hmm.
Number 2, transformational form of the trigonometric functions of x, or of f of x, is a sine b x minus c plus b. So yeah, like you were saying, that's essentially the same thing, except for we now have the b in here.
And were those ones like the second and the stuff, those other ones that aren't I guess the normal ones. See, I feel like I'm good with the vocab, and then we get to a point where I'm like crashing around.
Yeah. What was your question again?
Oh no, for number 2, the additional trig functions are like the second and then the cotangent, like the other ones. Are those the additional functions?
I'm turning my screen off, dude. It's gone now.
I'm not. Where's it asking for additional functions?
What problem are you on right now? What are we looking at?
We're just looking at the preparation activities, like just reviewing it.
Oh, okay.
Oh, sorry, I was on. I was ahead. Sorry.
Oh no, you're fine.
Yeah, I was looking at the quiz already.
Oh, we can start on the quiz if y'all feel comfortable with everything here.
Let's see. Yeah, I was on the instructions for the GHOA, but yeah, it told us to review the prep, but I was flipping between the two.
Oh, gotcha. Oh, that makes sense. Okay, yeah, let me go back. Instructions. For additional trigonomic functions.
Yeah, see, that's what I was wondering, but I was like, are those for like the second, cosecond, cotangent, and whatnot? Are those what they're referring to?
I'm gonna assume so. Right now. I mean, that makes sense, kinda.
Yeah, I mean, it doesn't really bring them up again in this chunk, but I guess it just wants us to know them for maybe we'll deal with them more in the next week. I don't know.
Possibly, yeah.
Okay.
So and then it says for us to review question 6 of the preparation activities. Does anybody have any questions about any of the preparation problem number 6?
I don't think so.
Yeah, I think with that one, I either get it or I don't get it, and I can't figure out why I'm not getting it. Like my answer is either right or terribly wrong, and I think it's just a focus thing. I don't know, but I'm working on that.
Well, do you have any like particular questions right now? Because it says we should discuss it to try and help each other.
Yeah. Yeah, we'll see. Like that's the hard thing with me. I feel like I'm working it out, but it's like a hit and miss. I'll either get the right answer or I won't. And I'm not sure exactly. I do the same process, but I think honestly, I think I'm just getting confused between the cosine, sine. I think I'm just not paying attention to what it is because that's throwing me for a whirlwind, but that's just me being rushing through, not paying attention.
Carry on. I'm fine. I'm independent.
Mm-hmm.
But I guess, I mean, I don't know, unless y'all have any other questions, if y'all want to look at the quiz, because like, for example, one of the quiz ones, I feel like what we talked about is here, and what it's asking is here, and I'm not sure how to draw the line between the two.
Let me take a look.
I feel like that's all math is. We're going to explain something that's this way over here, and then it's actually going to be done this way.
Yep.
Accurate. Oh my gosh. Oh, that looks fun.
You looking at the quiz?
Yeah. That's actually not that bad. Maybe. Okay. List the transformations made to the cosine function and write an equation of the form y. Oh, okay. So we just need to look at this graph and then pick out an equation that matches this graph.
Okay. Okay.
So it looks like it has a of 3. So the A is 3, I think.
Are you saying the A would be, hold on. Let's see. Two cosine. Three. So would the B value for that equation be 3? Or 3 pi? Is that the way we write it? Wait. No, scratch that.
So this
Wouldn't it have to be negative too, since it's going up and it's a cosine function?
Which part of it? Just the whole thing?
Yeah, it doesn't the negative at the beginning flip it, because doesn't cosine normally go down first? Like it goes down at an apex?
Cosine starts at 1 and goes down. I was looking at this top, like that top portion, and I think that's where it used to be at 1. So I think it's still positive.
Oh, I see what you mean, but it was shifted right.
Yeah,
Three.
it was shifted
Yeah.
to the right 3 pi over 2. And then it was like shifted, or it was like stretched. Which one? That would be B? No, B is the weird period thing. So it was, so D, oh wait, we have to figure that out. Okay, let me think about this.
Okay, I'm starting to see what you mean. And it's up 2.
It's, what was that?
Is it shifted up 2?
That's what it looks like.
Oh, okay, I see that.
Because if you shift it down, it'll go to -3 to +3.
Yeah.
And then the period is 1.
Would the period be 4 pi?
Why do you say that?
Because the I mean, since we can't see, like, you know, graphed in full, from the bottom of the left curve to the, or like, I don't know what you call it, the bottom apex on the left to the bottom apex on the right, that's 4 units of pi. So would that be considered one period, since it's the same point for one chunk of it?
Let me think about this.
Yeah, I think it is 4 pi because that's where it's going to repeat again. Is every 4 pi you're going to have the same repeats.
Yeah, I agree with that. Let's do it's 8 units. That would give you 4 pi.
So since a normal cosine, I think, is at 1, since it's, what did we say, 3 units, would it have been stretched by 3? Or a third, sorry? Is it a third or is it 3?
I think it'd be 3.
Yeah, wouldn't that just be stretched by a factor of 3? So like the, what's it, the A value? The A value would just be 3 cosine.
Hmm.
Yeah, that would, the A value would be 3, I think, too.
Yeah, that's what I'm thinking.
Because it's the vertical stretch of it, so.
And then do we have a B value? Oh, we decided that was 4 pi, right?
Cause that,
Yeah.
yeah, I guess. The B value is the horizontal. What is the B? Oh, that like affects the period. Yeah.
Oh, but then okay. Oh wait, 1 second.
Does the B value get plugged into the function? Because I feel like sometimes I see it, like I see the period as separate, but I don't know why it's got it like written with the function. I guess I'm confused by that.
Yeah, it should be. I'm pretty sure.
Hmm.
But I don't know if it would be 4 pi for the B value.
Yeah, I'm kind of thinking the same thing. Graph is given cosine.
Okay.
We should just have that. Should just have that one back left to throw in the washer and then a bit.
Yeah, see, so I plugged in my calculator 3 cosine of x minus 3 pi over 2 plus 2, which got me the right function, I think, but it's not. I need it to shift to the right. I didn't put the period at all, but it's still showing me with the apex at 5, the lowest at 1, with the same 1, 2, 3. I think it's showing me with the same period value, but for some reason I can't shift it.
Shift it
To the right.
to the right.
Okay, let me see. Oh, wait. I'm putting stuff in the wrong spot.
So the D value, would that be 2?
Yeah, I'm pretty sure the D value is 2.
That's what's going to shift it up to.
I think the only thing I'm confused about is the B value.
Yeah, same.
Which value is going to shift it to the right?
That's going to be the 3 pi over 2, negative 3 pi over 2.
The C value?
Yeah, the
See?
C value.
Yeah, see, I don't know why it's not shifting in my calculator. Let me see. I was trying to verify it.
So I think we have to put it into a fraction, actually, to get it to lengthen the period.
Yeah.
So, like 1/4. Let me try that.
Yeah, I feel like we've got the majority of it. We've got it good, but we're missing one part of it that I can't quite figure out.
Yeah, definitely.
I guess it would be the B value, I think. Yeah, when I plug it in on my calculator, it's not crossing the y-axis where it is in the problem. And I'm trying to tinker with it, and I can't quite get it to do that.
Where is it crossing in your calculator?
It's crossing at the apex. Instead of crossing how in the problem the apex is shifted at 3 pi over 2. I don't know why I can't get mine to cross at the right spot.
It's probably some super weird fraction.
Right?
Because why make things simple?
Let me try doing this. Oh, that's not it. Mm.
All right, the common sense of an 11-year-old. The S&P 500.
Well, I guess I can see why there's only 3 problems on this quiz. Given cosine function. Do y'all want to look at some of the other ones and come back to this one? I mean, there's only 2 others.
Sure.
Yeah.
See if maybe those will tell us something. Okay. Well, that is lovely. What is that, sine of alpha, number 2, or is that just A?
I think it's just A.
I have to say, I didn't learn alpha. Let's see. Sine of A, 2/5. Sine of A is less than 0.
Okay, so
So is that one part of the identities? Because I found some earlier that were sine of A equals cosine of pi over 2 minus A. And I don't know if that's necessarily the equation we use here. Sine of A is less than 0. I'm going to type that in.
so we know it's going to be in quadrant 2. What is that? I got negative square root of 21 over 5.
I got a
Anybody else
decimal,
got
but
anything?
huh?
You got what?
I got a decimal, but I can't turn it into a fraction for some reason. I got
What
a
did
point.
you-
I got a 0.9. Hold on. 0.99979, but I didn't get a negative.
Well, it has to be negative because it says the
Oh,
C is less than 0.
oh, you're right.
I'm not even sure I did it right, but What did you do to get a decimal?
No, so for that one, I had found some equations going through the book, but I'm not 100% if they apply for the situation.
Hmm. Anybody else get an answer yet?
Not quite yet.
Did you calculate it with the sine squared plus cosine squared with that function?
Yeah, essentially. Well, what I
Okay.
did here, wait. Now that you say that, I did the a squared plus b squared equals c squared, like for triangles. But oh, wait a minute. Yeah, let me try that. Sine squared of a plus cosine squared of a equals 1, right? So sine squared of a plus 2 over 5 squared 1 squared. Sine squared of a is 4 over 25. Using that method, I get the same answer that I got with the other thing, so it's basically the same thing. So yeah, I used the sine squared a of cosine squared a.
Okay. Sine squared a plus.
Did this go under or over?
That's it.
I got square root of.
I think it went on top of that, but I think that sheet went on top of
Yeah.
that.
This one on top of this.
No, the other one.
Negative square roots of 5 over
So this one's
3?
right on the board.
What is that even?
Negative square root of 5 over 3.
Yeah, but
That's not what I got. Hmm.
I don't know if I squared the tooth. Oh, yeah, I see what I did wrong. My 2/5 turned into 2/3 for whatever reason.
Oh, okay.
21 over 25. Okay, yeah. 21 over 25.
And then square it, or take the square root of it.
So here, let me check something. Yeah, the square root of 21 divided by 25. Well, would it be negative? Because whenever you subtract 1 minus, hold on, whenever you subtract the 1 minus 4 over 25, or 4/25, you get the 21/25, which the square root of 21 over 25 is still less than 0. It's 0.1833. So would it necessarily have to be a negative number? Because in the calculations, I'm not coming out negative.
That's a good question.
Because the number you're subtracting from 1 is still smaller than 1.
No, so it's less than 0, so it does have to be negative.
Oh, okay.
Yeah.
Okay, there we go. Yeah, so then negative.
And I'm thinking it's that way because when you take the square root of something, it can be either plus or minus that thing.
Oh, okay. And since they're telling us that sign is less than 0, that wants us to take the negative of the square root instead of the positive.
Yeah, so we ignore the positive part and we just focus on the negative, I think.
Okay. Makes sense to me.
All right. Question number 3. Use the fundamental identity to write two functions for cosine A in terms of sine A. Indicate which formula to use for the given value of A.
I already know the pack and play sheets,
Good.
So would that be what we're just doing? We're just showing how to get the cosine instead, like without working it out. We're just showing how to get cosine.
Use the fundamental identity to rewrite two functions for cosine. Use the fundamental identity to write two functions. What was the fundamental identity again? It's just the sine squared plus cosine squared equals 1.
Yeah, so like would one of the methods just be the cosine squared, sine squared minus the sine equal, like, so you'd find cosine with the square root of 1 minus sine squared? Is it just wanting like that format?
Cosine.
If we run across past that sheets, we'll get some.
Because I know those are the identities, but which formula to use for a given value of A? There are different formulas for different values?
For a given value, for just any value. Use the fundamental identity to write two functions. We need to write two functions for cosine A in terms of sine A. Indicate which formula to use for the given value of A. I honestly don't know what that's asking.
Yeah.
Cosine squared A plus sine squared A equals 1. And it wants it in terms of this. Okay. Possibly. I mean, that's the best answer I've got.
Yeah, it asks for another identity of cosine. I know there's another formula, but it's cosine of A plus sine A tangent A equals second of A. And I'm not exactly sure how that one applies, but I found it. But I don't really even know. That's the only other one that I can think of that has cosine also in it.
Okay. Hmm. Right, two functions. This is one function. Could you write out that other thing you were saying?
Hmm.
And show it to me?
Um, of course, my book doesn't want to load when I'm looking for it. No, it was like a weird, I don't even know if this one's even this particular identity, but it's cosine plus sine tangent equals secant, however you say that. But I'm not sure if that's also an identity or if that's just an equation. Because then wouldn't you just divide, or I don't know. That one doesn't make any sense to me. I mean, there's cotangent equals cosine over sine. Is that also a way to find cosine? Cosine in terms of sine.
Wait, okay. Value.
Yeah, the book's got product to some identities with cosine and sine, but that doesn't really make any sense to this either. So that's a huge equation. Yeah, there's like a dozen identities in here. Like, I don't know which ones. There's one for the spring motion. There's one for any object in motion. There's one for the sum.
Yeah.
Like, I guess fundamental identity.
Which is just the sine squared plus cosine squared equals 1. So is it
Yes. So how would we?
Go ahead.
Oh, no, I'm just trying to figure out how to get two functions out of that one thing.
So couldn't you just like alter the equation? So like, what is the this equation is sine equals what now? Plus or minus square root of 1 minus cosine squared? Or what was the equation you just said?
Sine squared of a plus the cosine squared of a equals 1. Is like the basic fundamental.
Okay. So could you just do like transfer that square root out of the sine? So just make it sine equals the square root of all that other stuff.
Oh, I don't know if this is necessarily it, but like if you switch it around where you have cosine of a equals the square root of the 1 minus sine squared a, well, the square roots have plus or minus. So what if it's cosine plus and then a cosine minus, and then it says indicate which formula to use for a given value. So if a is less than 0, use the minus of the square root. If a is positive, use the positive square root.
Yeah.
Sure.
Yeah, I'm grabbing at straws here.
That makes the most sense out of anything we've got so far. I'd say we'll go with that.
So kind of like this then. Wait, where'd it go? And I messed up my A's, sorry.
Yeah, and so like the positive one would be where a is greater than 0, and then the cosine negative would be where a is less than 0. That's my guess on that.
Yeah, that's what I figured, was just switching up the square roots and stuff to give you just different setup at least. Gives you, it at least gives us two variations of it.
Yeah, because that's the fundamental identity. So I imagine that's what we have to use, and that makes most sense.
So do we have to have two other equations? Wait, so Yeah.
I hope not.
No, I think that's
It
good.
says use to write two functions. And I think the plus and the minus
Yeah.
might be good.
And for that, going back to the graphing as well, I think for B, we can use, for what did I write down? 2 pi over 4 pi. Yeah. Good workout.
Which turns into 1 over 2.
And that's the value for you're putting in for B?
Yeah, because the equation for the period is 2 pi over B. Then I did that to give me the 4 pi over, or the 2 pi over 4 pi, which would be 1/2, I guess, if you simplify it. And I put that in and it matched up to the graph.
So then in the end, our thing would be 3 cosine
9 2 pi over 4 x plus negative 3 pi over 2 parentheses bracket plus 2.
And then the range just would be negative 1, 5.
Yeah.
It's got to be a better way to write all this than just waste so much paper, man. I just feel like I have just papers and papers of.
Yeah, I figure there's like 2 pages of notes every time I look at an assignment.
Yeah.
All right, then.
Anything else we're missing, or?
I think we just have to submit that.
I mean, I think our logic sounds good on some of those, so nothing more we can do.
Yeah. Who wants to submit that?
Let's see.
I didn't write down the second problem, but I can, I guess.
Second problem. Where is my second problem?
I think I might have everything.
Yeah, I'm like, I just would have to. I wasn't paying attention that much on the second one. I was trying to figure out the graph.
Okay. So just to like make sure that I've written everything down right.
Yeah.
So here's the graph problem.
3 cosine 1/2 x.
3 cosine is 1/2 x.
Hold on, let me go back and look at the way I wrote it in my. So what wait, hold on, where's the homework? So for that one, you want the b value, so the half, in between the bracket and parenthesis.
Oh, okay.
So it'll be bracket 1/2 parentheses x minus blah blah blah.
Why would it be like that?
That's just the way that the homework has it set up.
Okay.
Is the equation they gave us.
So like that.
Yeah. I have no clue why, but
Okay. And then I've got, where's my answer? It's, so I've got
And then
the
2 would,
negative square root of 21 over 5 for that.
and that turns into, yeah, sine squared equals 1 minus 2 over 3, or 2 over 5 squared, 4/5. Yeah.
And then for the, just making sure I understood it correctly, the cosine of A equals plus or minus the square root of 1 minus the sine squared of A.
yeah.
Okay.
Yeah, I don't know if specifically on that one, if you needed to do, where, here, hold on. Find sine. And let me finish this up. A less than 0. I don't know if you needed to do something specifically like this, where it's like the cosine of A equals negative 1 minus sine, and cosine is less than 0. And then the same thing without that, where cosine is greater than 0. I don't know if you had to like list them both out.
I guess it wouldn't hurt to do it.
Yeah, because it says indicate which formula to use for a given value of A. So I figure to have each formula with A greater than 0 and less than 0, because that's kind of what we did in number 2, and it told us that to use the sign less than 0 for it, which we kind of assumed to be the negative.
Okay, so one sec. Okay, so something like this.
Let me see. Cosine is less than 0. Yeah, exactly.
Okay. Sounds like a plan. Where do I put our names? I'll put it on this paper.
Awesome. I'll get the group video submitted with everyone's points and whatnot.
Okay.
Okay, and I'll go ahead and submit the quiz then.
Thank you.
Yeah, no problem. Anybody have any other questions?
I'm good.
Yep.
Well, good luck on the individual quizzes if you haven't already done.
Yeah. Oh, nice. Yep. Thanks.